Y'all, let me tell you about the molten salt nuclear reactor. Background: in a traditional nuclear reactor, the nuclear fission heats up water, turns it into steam, the steam turns a turbine, we get electricity. The basic principle of an MSR is pretty similar, but instead of there being water in the reactor, it's molten salt. And here's what's so cool about using molten salt. It can handle temperatures of over 600 degrees Celsius without boiling. That means that MSRs are incredibly efficient as they produce more energy with less fuel. And there's definitely variety in the MSR design features. For example, some only use molten salt as the moderator. Other designs take advantage of the molten salt properties and use it to dissolve their nuclear fuel. So this liquid salt is not only just acting as the moderator or the coolant, it's also the fuel source. Another neat safety feature is that if something were to go wrong, the molten salt would naturally solidify, stopping the reaction and preventing a meltdown. AKA, it's a passive safety system. Some designs still do use control rods to control the reaction, and other designs just rely on molten salt's innate negative feedback coefficient. MSRs can also recycle fuel from old reactors, turning nuclear leftovers into new energy. And they're believed to produce less long-lived radioactive waste. Sounds amazing, right? Why don't we have them then? Well, building these guys can come with some challenges. The materials need to be able to withstand molten salt's extreme temperatures and corrosiveness. We also need to update nuclear regulations because this is a whole new type of technology. And there's just the upfront cost of research and infrastructure. The Oak Ridge Laboratory actually ran a molten salt reactor experiment in the 1960s. But since then, there hasn't been a molten salt reactor in the United States. However, they are being developed. Kairos Power is a big player in this field right now. Posting a video on liquid metal reactors tomorrow, so make sure to follow.